Well, pre-calculus classes, as always, good morning, good afternoon, or good evening. In this last part of 4.3, I know I'd mentioned we finish it after we go over some of 4.2, and you'll probably kind of see the reason why. I mean, we needed all of the unit circle information before coming back to this, but we're going to go over and introduce what are known as trig identities. They're kind of like a geometric proof, but not entirely the same, and we'll certainly talk about those similarities and differences as we go. Now, what we do with this page is just kind of put all of the information that you're going to likely use in one place. Your reciprocals, I've already filled these all in. Sines 1 over cosecant, cosecant's 1 over sine. Cosine is 1 over secant, secant's 1 over cosine. Tangent is 1 over cotangent, cotangent's 1 over tangent. Your two quotient identities. Tangent is sine over cosine. Cotangent, again, because they're reciprocals, cosine over sine. Your cofunctions or complements. Again, sine's complement is cosine. Cosine's complement is sine. And I know when we gave you these back in, I think, 4.1, remember that pi over 2 and 90 can be used interchangeably. Tangent's complement, cotangent. Cotangent's complement is tangent. And then secant and cosecant. So, again, how these work. The sine of 60 equals the cosine of 30. The tangent of 60 would equal the cotangent of 30. The secant of 60 would equal the cosecant of 30. All right, the even and odds, or again, the opposites. Well, cosine is even, so it's cosine of negative theta is cosine. Sine is odd, so the sine of negative theta is negative sine theta. Tangent, because tangent is sine over cosine, well, a negative over a positive is negative. And I'm going to write secant is even as well. Cosecant and cotangent are odd. All right, your Pythagorean identities. Sine squared plus cosine squared equals 1. Now, again, the divisions. Well, if we divide everything by sine squared, sine over sine is 1. Cosine over sine is cotangent squared. 1 over sine is cosecant squared. And then if you divide by cosine, well, sine over cosine is tangent. Cosine over cosine is 1. And 1 over cosine squared is secant squared. So, like I said, I know this one, these two, I have to at least kind of reason through, but I don't think I've ever memorized these two in all the years I've been teaching. All right, so actually verifying identities. Now, I always like to say that when you start, what we are going to do is we're going to show the left side equals the right side. It's almost like when you start, we don't truly know these are equal. You can only work with one side of the identity, and you cannot move anything over. Now, there are usually a lot of different ways you can go about these. A lot of the times what, we'll see is someone will say, okay, well, tangent. Tangent is sine over cosine. Cotangent is cosine over sine. Well, sines cancel, cosines cancel, and you're left with 1. Now, I do not actually write what things equal until the very end. you are more than welcome to always write in the equals 1. And then what I always like to do is when I get to the end, I have my check mark verifying that does equal it. So the reason why I say these are kind of like proofs is, you know, you are showing the stepwise process. The only thing that you don't have to do, like the old 2-column proofs from geometry, is you don't have to tell us what you did. You just have to show the substitution. So that's probably the main difference. You know, you don't have the statement and reason, or the justification and the conclusion. I know different books I've taught out of use different terms there. So, all right. So, you know, example A here, fairly easy one. B is going to be a little more complex. Sine over cosine plus cosine over sine equals cosecant times secant. So, again, I'm going to show that these aren't actually equal. We're going to verify that they are. Now, you know, on the left side here, you usually have to work with, I would say, normally you're going to have to work with the side that looks more complicated. Well, up here, it's pretty obvious which side's more complicated. Here, I would say the two fractions, it's going to be a lot tougher to go from the right side to the left. So, we have two fractions. Well, if you see adding fractions, most of the time what you're going to need to do is get a common denominator. Well, I've got a cosine here, a sine here. So I need a sine here and here. I need a cosine here and here. So that gives me sine squared over sine theta cosine theta plus cosine squared. So basically, I'm just going to combine those into a single fraction since we have our common denominator. Now, from here, well, sine squared plus cosine squared is our Pythagorean identity. So in place of sine squared plus cosine squared, I can substitute in 1. All right, so now, with what's left? Well, I have 1 over sine, which is cosecant, squeeze my second c in there, and I have 1 over cosine, which is secant, which is what we needed. So again, here is an example where, like I told you, I chose not to actually write in what it equals until the very end. And again, one of the reasons for that is, like I said, you cannot move anything to the other side. So if you don't even write in the other side, you can't move something over. And again, the other thing is you can only work with one side. So don't start here and say, oh, okay, 1 over sine, 1 over cosine. Well, I can make this 1 over sine, 1 over cosine. So you have to work with the left side all the way until it matches the right side. Or sometimes there will be identities where you could actually pick either side. Again, there's more than one way you could do these. If from the start you had said, well, tangent's 1 over cotangent, great. Or cotangent's 1 over tangent. Again, there are not any set correct ways to do these, as long as you have a valid substitution process to go from one side to the other. So that's some introductory identities work there, and now we are all complete with both sections 4.3 and 4.2.